So this is Tim. Tim's going to take us on a tour of the new STEAM lab in the Lakeland College.
So welcome to Lakeland College. We are going to walk through. This was commissioned and put into operation here the summer of 2015. So we've been in operation for a year and a half. So she looks pretty shiny and new, and hopefully it's all good. What makes Lakeland's this STEAM lab very unique compared to any other college that's in Canada is we have a once-through steam generator. It's the only operational once-through steam generator that is in a post-secondary institution. And that is kind of the heart of heavy oil around Lloydminster, is a once-through steam generator. Are you guys familiar with once-throughs? Not at all? Okay. Think of an on-demand water heater in your house, right? It's a coil, and you simply circulate water through it. You throw a heat on it, and you put cold water in one side, hot water comes out the other side. Same thing. It's just a series of tubes inside of a contained burner, and it's all about water flow. So you flow water through it, you put heat to it. What comes out the other end at first is a little bit of warm water, then it gets hot water, and then it becomes steam and water. So the quality of steam coming out of a once-through is pretty crappy, which means it's a mix of water and steam. To pump it down hole, to loosen up a formation, to pump oil up, they don't care about the quality of steam. They just want the heat energy and the pressure out of it. So a once-through to run turbines and pumps and equipment, not great. It's got too much moisture to it. But this is about a 1/10 scale. It's a 6 million BTU. It'll do about a cube to a cube and a half of water in an hour. But all the operations, all the controls are identical to what's out in the field. So it is a really, really cool addition to the plant. But no school in Alberta or BC has a once-through, and of course anybody that's east of Manitoba has no idea what I just said anyway. So, right? So this is the startup tank for the once-through. This is your economizer, if you will, of a once-through. That's your main combustion area. Your burner's on that end, so that's where you get all of your convection heat, your radiant heat through there, and then most of the convection heat through here goes up to the chimney and out. And like I say, it's all about water flow. You have to have a continuous flow of water.
So do you have like a high pressure and a low pressure side on here?
No, it's all just one side. So you got a big positive displacement pump here. She just hammers that water through like crazy. Okay. So, and this thing is rated for 6,600 kPa is this operating pressure, but we would never operate that high. Our steam header is rated at 1734 kPa, 250 psi is the rating of this plant. So basically, the students just start it up, they run it, and then they shut it down. Yeah. We use the steam a little bit in operation, but I think only once just as a trial. But yeah, very simple operation.
Cool.
So this is our balance of plant. Basically, this is, you can control all the operations of the lab from here. And everything's all touchscreen, and away you go. You can turn on pumps, anything you want right from here. The same operations is duplicated in there, so that's a control room. So there's a two-operator, two-station operator control room, and each station has two monitors. Now, we've taken the BOP controls, moved them into there, and each individual piece of equipment that has a panel is also there. They can operate from there, of course, and most operators want the air-conditioned comfort, and because it gets hotter than a pistol out here when they're operating, and especially you get all the sun coming through this glass, you can get pretty crazy. So what we're operating here is we've got 4 high-pressure boilers. We've got our once-through, we've got an O-type traditional boiler water tube, a fire tube, and another D-type water tube. We've got 1 low-pressure boiler that keeps everything warm and toasty. In the evenings, runs our deaerator. All of our boilers have a heating coil to them. So the low pressure steam keeps them warm overnight. So in the morning, your startup is just hit go. There's a very slow, minimal startup warm-up time of maybe 30 to 45 minutes. That's it. So they can be producing steam within basically an hour of lab startup. And that's huge for students as they're coming in and coming out. They need to get going pretty quick. This is our once-through. Again, it's a very small-scale model. But the theory, the operation, the valving, the control is all 100% of what you'd see out in industry. It's small. Like I say, it's a 6 million BTU. The kind of the smallest that you're going to see out in industry is a 50 million BTU, and they'll go up to 300 million BTU. Like they're crazy big, some of these stuff. But your typical ones that Husky uses in the thermal projects that you keep hearing about Husky, they're typically a 50 million BTU. So that's the size of their vermin. Alrighty.
Then these are all the controls for your.
Yeah.
Yeah. I guess the colors of the pipe represent.
Yellow is gas.
Oh, that's the only
So
one
you're
for this.
using these are Maxon control valves. You've got pressure differential here, and that's about it on this side. There is the air-driven valves are on the other side, and you've got all kinds of flow meters and controls, and your PSVs down here. This is your main steam line coming out here. So when they're doing their startup here, they run everything into that tank. You don't run anything into a header because she's mostly water. So they run it into the tank until you get a quality of steam. And the maximum quality of steam you're going to get out of here is about that 80 to 85% steam, 15% water. So what you're going to do. We do have a steam separator up here. So if we do want to run some of our high pressure, we can separate out some of the water. And it goes down to the drain. You've got high pressure condensate, which will go back to our condensate system. And then this will tie into our high pressure header. Most times we're doing that because we've got some pretty high-end turbines and controls in here that we don't want to run a whole lot of water through. That is very destructive to operations. PSVs in here all get certified on an annual basis, so they have to get pulled off, sent away, recertified every year, and we've got quite a few of them in here. Alrighty. This is your feed water controls here for this boiler here is a traditional boiler. And what I mean by a traditional boiler, think of it as a kettle on your stove. It's a closed vessel. You've got water space, and then you've got a steam space on top, and you warm it up from inside the bottom, whatever, but it's contained in a vessel. So there's a volume of water in here. This is a water tube boiler. Are you guys familiar with the difference between a water tube and a fire tube boiler? No? Okay. If we look at it from the front, we'll make a little more sense. So feed water coming in, here's your feed water control valve, which is air operated, so you'll hear a compressor kicking on and off. A lot of the valves are air driven over electric, and your brains, your panel will control this according to level. Your water comes here, your water then will go up top, and it will go into an economizer, so your flue gases up through the top, that big canister, and as the flue gases are going up, there is a rad, think of it as a radiator going through there, so we send our water through an economizer, and it picks up the heat as your exhaust gases are going through up to the chimney, and then the water comes down and goes back in preheating that feed water. This boiler is rated at 10,000 pounds of steam, so meaning it can convert 10,000 pounds of water to steam in an hour. So how many gallons is that? 10 pounds to a gallon of water, so it could do 1,000 gallons of water in an hour. Now, if you're putting water at 30 degrees C in there, you're not going to do 1,000 gallons of water an hour. So we want to get our water as close to that 90, 95 degrees C as we can before we put it in the boiler. We extract all the heat we can from all over the place. All right?
Exchangers, folks.
Yep. So yeah, your economizer would be a very simple thing. So looking at it from the front, it's going to make more sense. So up on top, we have what we call our steam drum, your water level. If you look at your about the second left from the bottom, and that's the level of your water. So your water here is sitting right about that end of piping right in here. So all of this piping is all your pressure level controls that come down here. So you've got pressure switches, you've got level controls here, so it tells you what kind of water you got in here. So we're stacked up with water right up to that second left from the bottom. Steam drum on the top, mud drum, M-U-D, mud drum on the bottom. And to connect the two drums, there's about 100 pipes, and they're about 1.5 inch diameter pipes, and it looks like spider legs in there, and they just connect the drums from the top to the bottom. And the drums, the pipes of course make this O shape. These drums are centered symmetrically into the boiler, so we call this an O configuration. So our name for this one is the O boiler. And of course the pipes make an opening and your burner is right in here, so we'll throw a flame in there, and of course you get all that radiant area of the flame directly against your tubes. And then of course then you get the convection heat up through the economizer. So your tubes are full of water, so this is called the water tube. Okay? So every device here has its own control panel, own PLC, and this is how we would operate the specific boiler. This screen also is transferred into our control room. Okay, if you just step over here and turn around, you're going to see how we get water into the boiler. Is you can't just take normal water and put it into a boiler. If any of you have grown up on a farm or anything like that, where you take good old well water, you heat it, and it drops whatever it has in the water in the form of scaling. So a good old farm electric kettle will last about 6 months, and it rattle, and she burns up, right? So we have to remove all the minerals, mostly calcium and magnesium, the hardness of the water, we have to remove that. And then we take the water, run it through reverse osmosis, and then it comes up into our deaerator. So the deaerator, what it does is it trickles the water down to the top, and then we have a steam line coming in on the side here. It comes in, so the top vertical section is called the stripping section. So as the water comes in on the top, it goes through a series of trays, and we inject steam on the side, low pressure steam. It's only maybe 50, it runs between 50 to 75 kPa pressure. And as the as the water's coming down, you get a lot of contact area with the steam, and of course you're cooking the water, driving off the free oxygen. So when your water first starts boiling on the stove, you're getting little bubbles in there, you're releasing the free oxygen. Now we're not splitting molecules, we're not splitting the hydrogen and oxygen, but water contains free oxygen, and oxygen, hot water,